So we are going to continue with simplifying radicals today. So we're still staying in that idea of simplifying square roots. But today, instead of just looking at rational numbers underneath it, we are going to look at monomials underneath the square root, which means now we might have some variables and some exponents happening. The concept is still going to be the same, so we're not adding or changing anything there. We're just going to have to worry about the letter at the same time. So let's say that we want to simplify the square root of 60 x to the third. Just like we were doing yesterday, we are going to start with the exact same concept. So we are still going to start by prime factoring 60. That doesn't change. Okay, so again, you can split 60 into whatever you want to, right? I'm just ignoring that x to the third is even there. So 60, maybe I'll split up into 6 and 10. Again, it doesn't matter what you pick as long as mathematically it's correct. 6 splits into 2 and 3. 10 splits into 2 and 5. Okay, so my prime factorization of 60 is 2 times 3 times 5. And again, that's all just right. I'm just replacing how I'm representing 60 underneath the square root. Now, my second piece is going to be to prime factor the variable. The good news is, remember, we said prime factoring x to the third is super simple. We just write it the same number of times as there are exponents. Okay, so my x to the third becomes x times x times x. Okay, so now I'm here. And now I'm going to circle any pairs that I see. So just like we were doing yesterday. It's just that today we might have pairs that involve a variable. Okay, once we find those pairs, any pair that we see, we're going to pull out in front, right? So this pair is coming out here, and this pair is also coming out here. Now remember, when it comes outside of that square root, we are only going to write it down one time. So even though there were 2 2s, I'm only going to write down 1, right? 2 shoes, 1 pair, right? I have 1 pair of x's, so that x counts 1 time. Okay, and left underneath here, I have a 3, a 5, and an x. Right, and then our final rule was that we wanted to multiply anything that's in the same location. So the 2 and x just stay as 2x. That's all I can do to multiply them. 3 times 5 is 15. And so my final answer will be 2x square root 15x. Now again, whether that number is large or small, or the exponent or the variables is 1 variable or 2 variables or whatever, doesn't really matter. Okay, we're going to do the same process every single time. So let's say we want to do 3 square root 140 x to the 5th y to the 4th. So this one definitely looks a lot longer, but again, that process isn't going to change. So we're still just going to start off by prime factoring here. So I'm going to prime factor my 140. So that's going to split into a 14 and a 10. Okay, again, you could pick 2 and 70, whatever works. Okay, then I'm going to have 2 and 7, 2 and 5. Okay, so now I'm here. My 3 is still outside. I have a 2, a 2, a 5, a 7. Now I have 5 x's. So 1, 2, 3, 4, 5 x's and 4 y's. So it gets kind of long here underneath the square root. Not difficult, just takes up more space. Okay, and the next thing I'm going to do is I'm going to circle any pairs. So I have a pair of 2's, pair of x's, another pair of x's, pair of y's, another pair of y's. Okay, and anything that I have a pair of, I'm going to pull out in front. So this is coming out in front. This is, right? Every single one of those. So I already had a 3 in front, a 2's coming out, an X is coming out, an X is, a Y is, and a Y is. And left over inside, I have a 5, a 7, and an X. Right? Then anything that's in the same location gets multiplied. So 3 times 2 is 6. Now we have to remember our exponent rules. So when we multiply with exponents, we add. So that's a 1 and a 1, which gives me a 2. A Y times a Y gives me a Y squared. 5 times 7 is 35, and the X is just with it. So I get 6x squared Y squared square root 35x. Okay, so the process is very similar. Now, within this process, we have a couple of little weird things that we want to make sure we're okay with. Okay, so maybe we have something like the square root of 100, x to the 4th. Okay, and so we start by prime factoring. 2 and 50, 5 and 10, 2 and 5. So underneath I'll have a 2, a 2, a 5, a 5, and then, right, can't forget my variable, so 4 x's. Okay, now I'm going to find my pairs. So when I circle my pairs here, I have a 2, a 5, an x, and an x. So all of these are coming out front here. So a 2 comes out, a 5 comes out, an x comes out, an x comes out, and I don't have anything left to go on the inside, and that's okay. If there's nothing left to go on the inside, I'm not going to write my square root down at all. Okay, so I'm just going to multiply everything I have left. 2 times 5 is 10. X times x is x squared, and I just get a 10x squared. This was a perfect square. Just like the square root of 25 is just 5, right? We end up with an answer without a square root. Same thing happens here. Now, last sort of weird one. What happens if we have something like the square root of x to the 50th and y to the 27th? Oh dear, right? Option 1 is we could write down x 50 times and circle all of those pairs. I don't know about you, but I don't want to write down x 50 times and then write down y 27 times. That's a little bit of a lot of writing. Okay, so instead, if we're thinking about pairs, right? If I say how many pairs are in 10, we probably can just go, oh yeah, 5. Because the process of finding pairs is really just dividing by 2. So if you don't want to write down, because you have a large exponent, all those pieces, you can take the exponent and you can divide it by 2. That's going to tell us the number of pairs. Okay, so if I do 50 divided by 2, whether you do that in a calculator or in your head, we'll get 25. Okay, that tells us how many I want to bring out in front of the square root. Now, we have to be careful because my students will tell me that 27 divided by 2 doesn't work. Now, it does, it just doesn't work evenly. So if you think to way back when in elementary school, when you learned about remainders, and you would say that this is 13 remainder 1, right? And that 13 remainder 1 then turned into 13 with 1 over 2, right? We had 13 and 1/2. Okay. That remainder 1, that 0.5 is telling us that we have 1 left over, which means 13 pairs are coming out in front, and we have 1 left over on the inside. Okay, so if you'd like to use that option of dividing by 2 instead of writing it down 50 times and circling the pairs, you can always go that route to save you a little bit of time.